Hi everyone, welcome to this last developer session of the year. Thibaut here, and this is What's New in Octave, your live developer session about Octave, the edge-to-cloud data orchestration IoT platform by CR Wireless. If you attended or watched some of the previous sessions, you may know already our main presenter today. His team is in charge of Octave user interface, Octave UI. I've named my eminent colleague, David Bonnet. Hi, David.
Hello, Thibaut.
If you follow us on Twitter at the Sierra Developer account, you already saw a picture from the rehearsal of today's session. And you may know already that David will show and demo how you can implement a complex real state machine IoT application in Octave on a real use case, a gate opener use case actually. So very exciting. So I'm sure you'll have many questions today for David, either on this topic or on Octave UI in general. I saw some new guys who already joined. I used to ask a lot of questions, so please do this time as well. Send your questions at any time during the live using the question box. We'll try to answer them live during the session when we can, or we'll keep them for the Q&A session at the end. As usual, the session is recorded and will be posted on CR Wireless YouTube channel. If you are watching this session on YouTube, check out in the description below for the link to register for the live session so that you can interact with the presenter next time. Quick reminder, there's two ways for joining this session: through your web navigator or through a dedicated app. Prefer the app if you want to interact with the presenters. So without any further ado, David, the mic is yours.
Thanks to Thibaut. All right. So do we have the hand there? Yeah. So let's do a quick recap of what we deployed recently. We added new features to provide a better view on the operations and on the files. In particular, you can now upload and catalog files very easily. You can send files to the devices, and you can track their real-time status. And there's also a super simple pricing. This is what the files listing looks like. It's hierarchized. You can set up your files into folders. What we removed from the previous that we did previously were the file versions. So you'll notice here that there's no version anymore. The idea is to mimic what you have eventually on disk, and so what you have on disk are just files with unique names. So we wanted to replicate that and remove that versions feature. This is the operations view. So it really gives you super useful information. At first glance, you can list all your ongoing operations, filter them by type based on what you're doing. Either you're sending a blueprint, sending files, doing a firmware update, and you can see what is being involved in the operation and which devices. Well, here the filters are very simple, but sometimes you can also see the tag that is involved in the target of a specific operation. So this is super cool and a super big enhancement to what we had before. This is the operations view of a device, so that's completely new. There wasn't something like this before. Here, for instance, we can see the files being sent. I mean, they're already sent to a device, and when it's not done, you can track in real time the progress of the upload or the download to the device of the files. So you have a very complete view. And there's also a very simple pricing. So it starts with 50 cents for the first megabyte for the first file, and then 25 cents for the extra, each extra megabyte. So it's a very simple pricing. You can, based on the files that you wish to send and based on how many times you want to update or upgrade your assets with some configuration, if you know the size of your files, you know how much this is going to cost, alongside the rest of the message and solution fee. All right, so that's operation and file. It's now in production. You can use it on the UI very conveniently. Now I would like to talk about edge actions. So what we did is to upgrade these edge actions and to have them accept multiple inputs. Currently, you can only create one edge action for one observation that has to be set up specifically to send to an edge action. Now you can accept or declare many inputs, and not only observations, and actually any observation could be also observations to the cloud that push an event directly to the stream. You can use also that as an input to an edge action, but also resources. And well, we have Ian, our edge developer. At first, he came up with because he developed the part on the edge side, and he said that, well, the limit is going to be 8 inputs per edge actions, and so we said, yeah, it's a bit low. 8. Can you do like 20, 30 at most? And he said, well, okay, I'm going to see what I can do. And the day after, he came up with an update that enabled 64 inputs, so either resources or observation and a mix of both, to be used simultaneously across all the edge actions on a single device. So given all the constraints, the memory constraints that we have on the device, this is quite a remarkable feature there. And then, well, all this is available, of course, only on the next upgrade of the device firmware. This will be 3.4, and it's currently in preview and will be available early next year. This is what the UI looks like of the edge actions. So you can see at the top now, you don't have an observation selector, but you have well, a preview of what the resources are. So like the first one, and then here a badge telling how many more resources or inputs are being used. And if you use that toggle here, it shows this table. This table also not only lists the resources or observations, but they also show the current value, which can be quite convenient while we're developing on an edge action, and also the timestamp of the last reported value. The editor also got more intelligent. Now it focuses only on the body of the function, so you don't have to mess around or consider the declaration of this callback, like function event. Well, the downside is that now the parameter will be event all the time. If you have current edge actions that don't that have a function declaration where that parameter has been named to something else, like a raw event or sensor input or input, don't worry, this has been renamed automatically to ensure that the function still works when you update it in the new editor. And the cool thing with that is that we can add information about this event parameter right inside the code. So users know that there's a timestamp, there's a value, and there's now also a source property telling you from where that event came, from which resource, because you can declare many. And it's also super helpful. It provides you autocompletion based on that source, based on the declarations you made there, so you don't make any errors. All right. So furthermore, how do you add input? So here we have the input selector, which by default lists you all the resource inputs, but also the observations on these resources. And there are 2 special items that you can select. There's one that enables to add any resource that matches that that pattern that you wrote there, or you can also add a resource that doesn't exist yet. So this can be useful in case you're using ORP, for instance, where sometimes the assets, well, it's not running or it hasn't declared yet the resources, but you know them already, so you can declare them and add them as a source there. The other thing is in the listing, this is how an observation looks like now. It's not just the name of the observation, but it also shows the resource path that it's observing. When you hover over that name, you get to see a card that gives you the settings of that observation. So you don't have to go to the observation and to see, okay, what is it doing? So you have the setup, you have the values, you have the timestamps, you have all the information available in this one editor ready for you to be used in order to configure your edge action.
Kevin?
All right. Yes.
Quick questions for you. If your observation is based on a resource, why use observations if you can use the resource directly?
Well, observations are, I mean, you can set up a buffer, you can set up a throttle, you can filter them, and so that they are still meaningful. So you can rate limit the number of time they get triggered. If you have a resource that triggers every second, but you only want one value every 60 seconds, for instance, well, you can just use an observation, sorry, and it will be much easier to use that instead of making a complex filter with edge actions. So there are some properties, some functionalities that observations have, and they're ready to use. So it can still make sense to go through an observation instead of directly connecting to a resource.
Sure. Quick other question on the UI before we jump to the other subject. Would be nice to have an hyperlink on the device from the operation view. On the operation.
To the device from the okay. So let me
have an hyperlink. You can click directly on the. It seems like it's something.
Is that the comment? Well,
yes, just a
I
comment
guess
on
but
the UI.
maybe not. Yeah, you're right. Maybe not there, but if you go to the to an operation detail, you can jump to the device usually. So okay, it requires a second click, but yeah, the idea is that you can reach any device from an operation because all the operations target the device. But
well,
yeah,
that's always useful to see you guys asking questions, and you are using the UI every day, so that's really useful for us. So thanks.
It's always nice to look for improvement. Okay, so now with all that, let's jump into the demo. I'm going to reduce the view here, and oh no, I exited too fast. So I'm going to explain the context of this demo. The idea is to control a gate with a motor that is here, and that the green bar here is the gate. There's a fence, of course, and here's the alley, and that's the street. So you want to control the access to that alley. We have some proximity sensors which trigger whenever there's an obstacle that is located here. And there's also a remote control that enables you to open or close the gate. So for this demo, we're going to use Modbus, and the proximity sensor is going to be a single server, separate server, the motor as well. And so the proximity sensor exposes only one register, which is a coil register, so it's a discrete input-output that you can update. And the motor has like 3 registers that we put each in its own group so that we can name them. So the power, the position, which is actually the angle here, and the current current consumption, how much current is absorbed by the motor in real time. And here we have a receiver, which also triggers. So here again, as for the proximity, it's a coil, a discrete input output that will you can read from and you can also write from. I will explain later why it's not just a discrete input. All right. So we're going to start with a simple state machine. So this is really naive, of course, because if you're in the gate business, well, you clearly know that there are many more states than that. But in order to show how to use these edge actions with multiple inputs, we're going to start simple. So we have a closed state, and then something like a button push will trigger the gate to open. So we enter an opening state, and while it's opening, we're in that state. And then once it's completely open, it goes into the open state, and then again, if we, for instance, push the button again, or after some time, or another reason, then it will start closing, and then it's back in the closed state. So this is what we're going to model right now. All right, so let me turn on the camera so that you can see the FIC30 Ethernet that we're going to use. This is the device. And let me zoom in a little bit. There. Okay. And this is our demo right there. Okay, so we're going to jump to the actions. So as you notice here, I'm running a firmware 3.4 preview that got released earlier this month. All right, and we're going to create a new edge action. So here's my source toggle. This enables me to show the source listing. So at first there's no source, and so we're going to use some registers that we saw earlier. So here, what's interesting is I started to type mod for Modbus. I can continue start typing Modbus, and here I can add 9 resources matching Modbus. So I can add all the inputs at once. And so why go through this hassle of adding a lot of resources at once? Well, if we can deal with 64 inputs, then of course we need to provide a way to add them very, very easily. But here we have too many resources, and so we're going to remove a few of them. With the Modbus server, you can send requests, you can update things, and we don't need them here. So we're going to, especially here, these are the request acknowledgement resources that we don't need. So I'm going to filter them. Okay, there are 3 of them. I'm going to select them all, and I remove them. So that way you can very, very easily trim your selection of resources to the ones you need. And here we have some observations that got added as well, because now you can look for an observation not only based on the name of the observation, but also based on the resource path that is being used. So here we have 3. We don't need them. We're going to remove them as well. Boom. All right. So we need, as an input, we need what do we need? Well, we need a button, and we don't need the proximity. That is not useful. So we need to know when the motor is being pushed. And then the other thing is that we need the motor, because we need to know when the gate is completely open in order to transition from the opening state to the open state. So we're going to need that. And we are also going to need something else. We're going to need a state. So that's going to be a virtual resource that stores the actual state. And here you can see that it's in the closed state, which is convenient because our gate is closed here. And that resource is named conveniently virtual/state/value. So we're going to need that as an input as well, because we need to trigger that edge action whenever we move to another state. So let me add that. So here again, I could also add a resource that does not exist. This is what we just did here. Very easy. Okay, so virtual, yeah, state. Let's add that. Okay. So now I have all my three inputs that I need. I can see the actual values. So the button is not being triggered. The data is 0. The current is 0. Well, if I remain here, I can see okay. The position is at 1000. So it's I mean the normalized value of 1000 is 0. And the power is 100, so its normalized value is 0 as well. Okay, so let's now add the code. So of course, I'm not going to write everything there. I'm going to use a set of helper functions in order to simplify how I write my code. And I will explain you what these helper functions are doing. So our code will consist of two parts, states and transitions. Let's start with states. So for states, we're going to check whether the event that we just got is coming from the virtual state resource, meaning the state just changed. And here you can see that the editor is providing useful suggestions, for that even source, and it's based actually on what I defined earlier in the sources table. So here I want to use that, and now I want to switch over the value of that event. So here the event value is a string that holds the name of the state I'm in. So let's start with the case where the gate is closed. Well, when it's closed, I want the motor to be shut down. So I'm going to use my helper functions, which I will show you shortly. I mean, in a few seconds. So here I'm going to write on register, and I will set the power to 0 using the module service. So if we look at the implementation of that, write power actually uses write register. 5:30. And here we can see that it's actually writing on a specific Modbus on the motor resources in that case, and it's going to post or write a write command on a specific address and with a specific register type, the value that you provided. So for the power, it's going to write on at the address 0 of the power register group, and so it's a holding register, and here we apply the conversion because a power of 0 is 100, so that's why there's a plus 100 here, and I will explain later how do we close the gate. Well, actually you set negative power in order to get the motor to move into the other way. Okay. And since these are unsigned integers, well, you cannot, you have to shift a little bit. So here we're shifting by 100 so that we can express some of the negative numbers as well. All right, so here when it's closed, we write the power, we set the power to 0, so we stop the motor. And this merge function, well, here it's not very useful, but it enables us to very conveniently merge different requests as these into a single object that gets returned. So instead of writing very complex things every time, here we have a very concise way of expressing what we need and what we're looking for. All right, so when the gate is closed, no power, the power is shut off. Good. Now, let's see what happens when we start opening the gate. Well, when it's opening the gate, we're going to turn the power on to say 20 volt, for instance. And there's another thing. We have to write to set the register that that detects the button. When you push the button, it sets the register to 1. But when you release the button, the register stays at 1. That's how our setup works. And the reason why is that we let the state machine acknowledge that it got the reading that the button was pushed by setting the register back to 0, since the Modbus register are pulled. All right, so this is this describes the state of the resources when the gate is opening, and then at some point the gate is open. So we're going to consider that case. And well, when it's open, it's the same as when it's closed. So we need to shut down the motor. So we're going to set the power to 0 again. And then we want to close the gate. So we're going to name that state closing. And here there are several things happening as well. So we close the gate by, say, pushing the button again. So we have to acknowledge by setting the register back to 0 because it was set to 1 by pushing the button. And in this case, we're going to set a negative power value here. All right. And in case we are in a state that we have no idea what that is, well, then we just return. And so we can specify here that it's an unknown state. And we don't do anything else. All right, so here we described our states. And for each state, we defined the wanted values of our resources. So these don't leverage any inputs to that edge action. There's just the state, the virtual state resource that we're using here. But now we are going to consider the transitions. And we're going to fall into that case if the event that triggered the edge action doesn't come from the virtual state resource. And so here we need to switch. We need to have a specific behavior based on the actual state. So I'm going to use the resource API, and I'm going to use the read value function. And well, here it's kind of nice because it's auto-completes and it shows me all the available resources on the device. And I'm going to use this one. Well, the state. So we're going to read the state, and then we're going to switch over the value of that state. Read value returns immediately the value. So in this case, it returns the string, which should be either closed, opening, open, or closing. All right, so here in case it's closed, we're now going to describe the possible transitions there. So here again, I'm going to switch over the event source, and I'm going to use a case. And well, when it's closed, we want to start opening the gate when you push the button. So here I'm going to use the Modbus, and again I have a nice auto completion. So when I push the button, so that it will trigger an event, and will trigger this action with an event coming from that resource. And I'm going to check here if the register value, because this is a server, actually, a Modbus server, and I'm going to check if the specific register value, so in the group trigger, and by default, this function only considers the first value. I'm going to show you quickly the implementation. Every time these are 1 or 2 line functions, or I mean at least 1 or 2 instructions. I mean at most. And then here, when the value is non-null, we're going to transition to another state. And in this case, we're going to transition to the opening state. Right. Let's reformat this a little bit. Okay. Okay, so when I'm in the closed state, I get an event from the button Modbus server, and its register group trigger has its first register set to a non-null value. In this case, it will be 1. Well, in that case, we want to transition to another state, opening. So what is this transition to function doing? Well, it's just writing, it's just updating the virtual state resource to that new state value. Okay. So, and in case that button got updated, but doesn't have a truthy value for its trigger, then we don't want to do anything. So we just return and stop there. All right. So this will enable us to open the gate, but while it's opening, we need to well, to stop the motor at some point. And so that's why we need to consider now the transitions in the opening, while we are in the opening state, sorry. So here I'm going to do that. I'm going to switch over what? So here I'm going to use the auto completion, and I'm going to consider the angle that the gate is making with the fence, and I get that from the motor Modbus server. So that's why we're targeting this resource. And now if the register value that is in that event located in the position group is above 1,000. So here we use 1,000 as a base, and then 1,000 is 0. So if it makes a 90 degrees, then we have to do this computation. Well, in that case, we transition to the open state. So every time we transition to another state, it updates the virtual state resource, and then it triggers here, and then in turn updates the resources based on the value of that state that was written in that virtual resource. So here already we have a behavior that is able to open the gate, sorry, and to stop it when it's completely open. All right. In case well, nothing matches, we have to return here, and we have to do the same here as well, and here as well. All right. Let's reformat this a little bit. Okay. Good. Now we have 2 more transitions to consider. There's the transition from the closed state to the opening state, and then the transition from the opening state to the open state. And now we want to eventually close back the gate, right? So we have to add another open state, and then we use switch. We switch over what? Well, the source of the event we just got, and so here we're interested in the button. Up. And so it's going to be similar to what we have here. When it's triggered, we want to not transition to the opening state, but to the closing state. So whenever we push the button, we start closing. All right, and here we return. And then we have the latest transition. You might guess already what it looks like. So we switch over the event source. And here it's pretty similar to what we have here. So I'm going to copy paste that. Boom. And here it's when the position is not 90 degrees but 0, and it's lower or equal, then we transition to now. Okay, so this should be enough to describe the behavior of our gate opener. So we're going to check if there's everything there. Yeah, and we're going to call this gate demo, for instance, and save that. So it's enabled by default. It should be all right. Okay. So there's our gate. One cool thing by using states is that if you observe that state, you can debug very easily your machine. So we're going to go here. This is our state stream. So there are too many things here. What we're interested is in the value of that. Yes. All right. Okay. Okay, so let me update that stream and set its capacity to, like, say 5. Hoping that will flush a lot of events here. Okay, so now let's see if it works. We're going to push that button, and we see that the gate is now opening. If we check here, we have an opening, and now the gate is completely open. And now we see that we just switch to the open state. So now I can, whoops. Now we can trigger and close the gate. So I push the button, and now it closes. All right, so it's doing what we ask him to do. Well, now what about adding more things? So the advantage of having such well, simple code structure is that you can then also update it very easily. So here, what is kind of annoying is that you have to push the button again in order to close the gate. So what if you open it and you enter and then you forget to push it again? Well, you ideally would like to have the device close it after some time. So for that, we're going to use a timer. So here, if we go to the resources, we can see that we have a timer somewhere that is being configured. So let me show you the configuration of that. So that timer is called close. It doesn't start automatically, and it has a period of 10 seconds, and it repeats only once. So we're going to trigger that timer when the gate is completely open, and so that it starts closing again. And we're going to update our state machine to reflect that. So first in the state, when we enter the open state here, what we need is to start a timer that will to start our close timer that will trigger that edge action later on. And in order to trigger it, we need to add that timer here. And it's not this one, this one, close timer, close value. You can see it, the value is 0. All right. Okay, so now we have that timer that will be triggered when we enter the open state. But now we need to listen for that timer. While we are in the open state, we need another transition that will trigger the transition to the closing state. So here we just added the timer resource. So this is this one, and so here we need to check if, because the timer also triggers when it's set to 0. So we need to track and make sure that the value is non-zero. And then in that case, we transition to the closing state. So we just copy that here. All right. And in case the value was 0, then we do nothing. We just ignore that event by returning here. All right. So let's reformat, save this, and let's see what it does. So there's a snowman appearing, and as you can see, nothing was preventing the gate from crashing the snowman. So that will be our next thing. So here the gate is completely open. I'm not clicking that button, and after 10 seconds, you can see that it's closing again. All right. So
snowman surprise.
All right. So how do we prevent the snowman from getting crashed? Well, we have these proximity sensors. So let's add these. So we just update our states. And as you can see already, it's very easy to update the code thanks to the multi-input for edge actions. So here I'm going to use a write proximity function that will, similar to the button, acknowledge the fact that, okay, we got the signal from the proximity sensor. So we're now resetting that to make sure that we can be triggered again by the sensor. So it's the same thing as the button. And so that's when we are on the closing stage, because the behavior is that the gate opens, the snowman appears, and so let me show it. Yeah, no, I will show it later on. And while the gate is opening, and so the behavior is that the gate stops opening and starts closing again. So in the closing state, we acknowledge the fact that, okay, we got the signal from the proximity sensor or not, but we reset it to 0 anyways. And then while we're in the opening state, we're looking for a transition to the closing state. So I'm going to add a case here. And oh, I need to add another input. And in this case, it's going to be the proximity sensor, this one. Boom. All right, and you can see here already there's an obstacle register group. It's a single one, and it has a value 0. Okay, let's close this again. Okay, I just added that. So now I can use the proximity here, and so I can read that register value, and that register value is called obstacle. And well, if it's a non-null, well, I'm going to transition. I mean, it is going to transition to the closing state. All right. Yeah. And then in case it's already null, then we do nothing and we just ignore that event and we stop there. Okay, let's save that. Okay. So now let's push that button and let's have the snowman appear. Ah, no, it's not working. So what happened? What happened? So let's check the streams, the state streams there. Or maybe I was I did it too fast. Okay, I can push the button to trigger closing it. No, closing. Hello. Okay, let's check the server. No, everything's all right.
The snowman bug.
So what is wrong there? Ah, the button is still 1, and we are in the closing state. So something is weird. Okay, so let's update that state manually by pushing a command. So in that case, it's going to be open. And now if I trigger that, even though the button is already set to 1, no, that doesn't work either. So far everything went all right. Let's check the streams. State. Okay. Well, let's restart the Modbus simulator. Maybe there's an issue there.
At least everyone can see it's a real live demo.
Yeah, it is. Okay, so now it's in the closed state. All right. Or maybe it took some time to update it. Okay, let's. Did I put it in the right? Yeah, I did. So let's try again. We'll see. I'm just save the snowman there. Oh, no, it's in the closing state again. Ha. Okay, so maybe I might have missed something. But what?
All right. As there is only 5 minutes left, maybe if you guys have any questions for David, I think it demonstrates really nice new features thanks to the possibility to have several resources now in ejections. Implementing such machine state machine code is really easy. So that's opening a new range of possibilities. That's I love that actually. It's really it's great. While David is trying to figure out what's happening, any questions for you guys? Ian is saying it does make a great difference. Thanks, Ian. By the way, Ian, he's the one who did with us the last session. So thank you for joining again today. Thanks, Ian. Anybody else with questions for David on the UI? Can be a general question as well on the UI, not only on the features demonstrated today.
Ah, okay.
Oh, it works. You saved the snowman.
There it is. All right. So yeah, maybe something. Yeah, demo effect as usual. So sometimes when you don't have enough time to check what is going on, what you miss, probably I miswrote something or didn't see, but anyway, yeah. And then you can keep extending it, like while it's in the opening state, you can set the light, for instance. Do we have a light here? Or maybe not. So I'm going to pick up this because this is why we're seeing the FX 30 on the left for all this time. So here we have our we have our light time. So for instance, here, if it's stopped, we want to set the red light to null. If it's opening, I think green is the one we're looking for, GRN. Yes, we want to set it to that. And then when it's open, we want to shut down the light. And then when it's closing, we want to set that light, for instance. Voila. So it's very simple to extend the state of the resources based with when you're dealing with a state machine. All right, so if I save this now, I do that, and now if we pay attention to the
So we have a question, and the answer is yes. It's going to be a commercial availability feature. So what David said is that's a preview so far. but it will be released for everyone. It's going to be available to everyone. So for now, if you want to access to the preview, as David said, just contact us. You can contact us on the forum or here, and for sure we'll make you access to this preview. That's the answer to your question.
Yeah, the UI update is available, will be available today. We have actually also tiny new thing for users that are not using the latest firmware. So here, for instance, I'm using 3.2. If you go to the actions, and let's see, well, that light action, we now can see the reported value of that observation and its reported timestamp as well. So at least you get that if you're not running the latest version.
Thanks, David. Should we stop there, or do you have?
Yeah, if there are no more questions, I think we showcased the multiple inputs of edge actions.
So thank you for this demo, David. If you guys have more questions, feel free to contact David and the team on Octave forum. As usual, everyone is on the forum and try to answer your questions every day. The whole team actually, so that's great. I think we can jump on the last slide, David, and wrap up this session. And yeah, that was the last session of the year. We'll see you next year. We don't have yet the date, the exact date, but we'll come back to you with the date. Remember to register for the next live session. So you will have to register actively for the next session when we'll have that date. As usual, follow us on Twitter, CR Developer Twitter, and on our YouTube channel. Please register to CR YouTube channel if you did not already. And this video will be posted as usual in the coming hours. And that's it. Thank you everyone for joining today. Thank you, David, and thank you for the snowman, for the. Hopefully you will fix your code and you can definitely save it.
Yeah, we're going to document the practice of describing state machines in multiple sourceable edge actions.
And all of that is going to be available on Octave documentation, right?
Exactly.
Excellent, excellent. All right. Thank you, David. Thank you, everyone.
Bye, guys.
See you soon.
Bye, everyone.
Bye-bye.